Unmuted. Hello, am I audible?
Yes, ma'am.
Okay, so let's start. Yes, what is the last point? I think we have finished double hashing.
Yes, ma'am.
Okay, wait a minute. Hello, am I audible now?
Yes.
Yes, ma'am.
Yes? Am I audible?
Yes.
Yes, ma'am.
Okay. So let's start with the double hashing. Uh, Let me open the Meet on my phone. I will share my screen. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Hello? Hello?
Yes, ma'am.
I think there is a problem of echo.
No, ma'am.
No?
No, ma'am. It's clear your voice.
It's okay. Okay. So let's start. We have, I think we have solved one problem, no? Double hashing.
Yes,
We
ma'am.
have started it.
We
Yes,
ended it, ma'am.
ended it. 17. Okay, okay. So, should I go ahead or should I explain the double hashing again? Is there any problem with double hashing?
Just repeat in short, ma'am.
Okay, can anyone please tell me what is the double hashing technique and which two formulas we are going to use for find out the H1 key and H2 key?
H2 key is equals to key mod table size,
Yes, this is H1,
and H2 key is equal to M minus key mod M.
key mod M. Yes. So suppose your numbers are 37, 90, 45, 22, 17, 49, and 55. And if your mod function or hash function is mod 10, that is the table size. So according to the function, you can place the values at that particular index. So 37 at index 7, 90 at index 0, 45 at index 5, then 22 at index 2, then 49 at index 9, and now to place 17 and 55, you need to use the double hashing function, isn't it? Because these two fields, index 7 and index 5, are not empty. They are occupied by the previously placed keys. So for placing 17 and 52, we are going to consider the second function, that is the double hashing function. So H2 key Now let's consider the number is 17, this number. So H2 key is equal to M minus key mod M. So what is M? Yes, what is the value of M?
Prime number.
Prime number smaller than the size of table. Now your table size is 10. So which is the smaller number? Less than 10? Prime number, that is 7.
7.
Yes, so 7 minus key is 17 mod 7. 17 mod 7 is 3. So your value is 4. Now 4 is not the index. So what is this 4? You have to take 4 jumps after the actual index of 17. Actual index of 17 is 7. So after 7, you need to take the 4 jumps. That is first, second, third and fourth. So this is the location. So here I can write 17 by using the second hash function. Like this. Now 55 mod 10 is equal to 5, but at index 5 we have already placed 45. So you need to find out the second location for placing 55. So I'm going to use the mod second hash function. H2 key is equal to M. M is 7 minus 55 mod 7. Is this correct? Yes. Is this correct?
Yes, ma'am.
Yes. So 7 minus 55 mod 7 is 6.
6.
Yes. So 7 minus 6 is 1. So now what is the actual index of 5? Is 5. So take one jump. Take one jump after 5. That is location 6. So here we can place 55. So this is the simple concept of double hashing. Got it? Yes? Is this clear?
Yes, ma'am.
Okay. Now let's see some comparison points of the quadratic probing and the double hashing. So the double hashing requires another hash function whose probing efficiency is same as some another hash function that is been required for the handling the random collision. Okay, but while and double hashing is more complex to implement than the quadratic probing. Why? Because we are going to use the two different hash functions. The quadratic probing is fast technique than the double hashing because there is only one hash function. So these are the important comparison points of quadratic probing and the double hashing. Okay. Now after this, the next part is rehashing. Rehashing. Now rehashing means exactly what? It is a technique in which the table is resized. Table is resized. Please note down these things in your notebook. Table is resized. That is what exactly resize means. The size of the table is doubled by creating a new table. Okay. For example, now suppose this is your table. This is 0, 1, this is 2 and up to 9. Okay. So I'm going to name it as an old table, and in rehashing you can increase the size of the table. So this is 0, this is 1, this is 2. Suppose the size is last is 22. This is new table. And you can transform the content of this old table to the new table accordingly. Suppose this is field 2. So it is preferable that if the total size of table is a prime number, then okay, there are some situations in which the rehashing is required. Okay, let's see first those situations why we are going to use this rehashing technique. If your old table, suppose your table size is 10, that is from 0 to 9, and if it is this table is completely full, then you need to resize your table, and there are certain rules to resize this table. Okay, so when your table is completely full, then it is required to rehash. With quadratic probing, when the table is fully halved. Now, in quadratic probing technique, what we have done in quadratic probing? Do you remember? Yes, what we have done in quadratic probing? Hash key plus I square mod m. Have you remember this? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Yes. So while applying the quadratic probing technique to insert the numbers or keys in the hash table, we require the rehashing. That is, we require if your table is filled half itself, then also you need to apply the rehashing. Okay, that means you need to increase the size of your table. When insertions fail due to the overflow, that means if your overflow means again the same thing, that is when your table is full. In that case, overflow is there and you cannot insert the more numbers in the table. Okay, so in such a situations we have to transform entries from old table to the new table by their new positions. Okay, and that new positions can be calculated by using the hash function. Okay, for example, now again consider the values. Suppose 37, 90, 55, 22, 17, 49, 87. Okay, and the table size is 10. Okay, let's use the hash function as h key is equal to key mod table size. Key mod table size, that is 10. Okay, so how you are going to place these numbers now? These are the indexes. Your first number is 37. We are going to place this at index 7. Second number is 90 again. So here at index 0, 55 at index 5, 22 at index 2, 17. Now for 17, you cannot replace it at index 7. Okay, so collision is occur here. So to solve this collision now, I am going to use the linear probing technique. So what is the linear probing technique? Linear probing technique means it is a simple way, that is whatever the next empty position, you can place the next same index number at the next empty position. So if my index is 7 for number 17, I can place 17 at next empty position as 8. So I am going to place 17 at position 8, which is the next empty position. This is a linear probing. Got it? Probing means we are just placing the number or inserting the number in the hash table. That is the meaning of probing. Now next number is 49. So 9 index is empty. I am going to place 49 here. Okay. Got this? So after 49, next number is, now if you see, your table is almost full, and if you try to insert more elements, collisions will occur. That means eventually you can say the further insertions will be failed. So we will rehash by doubling the table size. The old table size is 10, then we should double the size of the new table as 20. But 20 is not a prime number. Okay. And according to the rule, whatever the size we are going to change, or whatever the table, if you want to resize it, the new table size is a prime number. It should be prime number. So for table size 10, if you want to double it, that is 20. The next prime number of 20 is 23. So you can consider the new table size as 23. Okay. So we are going to prefer to make the table size as 23, and your new hash key, that is hash function, is hash key is equal to key mod 23. Okay. Now let's check the values now. Now again, you have to check the mod function. 37, 90, 55, 22, 17, 49, 87. Mod 10, 37, sorry, mod now 23. Mod 23 value is, yes, tell me the answer. 37 mod 23. I think it's 14. Yes. Now 90 mod 23. 21. Is it correct? Am I correct?
Yes.
55 mod 23.
9.
9. 22 mod 23. It's 22.
0.
Yes. 22 mod 23 is 22. Correct?
Yes, ma'am.
17 mod 23 is 17. 49 mod 23 is
3.
3. And 87 mod 23 is, yes, what is the value?
18.
18, correct. So these are the indexes in your new table. Okay. Now your new table is sufficiently large to accommodate the new insertions. Like if your index is 22, then you can place it at, now your table is from 0 to 22. So here last index is 22. You can place it. Okay. So that means you can say this technique provides the programmer flexibility to enlarge the table size whenever it is required. Okay. And only the space gets double with the simple hash function, which avoids the occurrence of collision. Okay. So let's solve some problems of all these hashing techniques. Okay. Take the first example. Now Okay. Just wait a minute. I will give. Please check. Is it visible? Yes. Is it visible? Check the statement.
Ma'am, it is totally blur.
Yes. Now?
Yes, ma'am.
Now it is visible.
Yes. Please note down this statement. Just go through that statement and try to analyze the statement. Then we will solve it. Okay? Just think about the example. Finish writing? Yes. Finished?
No, ma'am.
Okay. Okay. Take your time.
I'm completed.
Okay. So let's solve the every bit one by one. Your first statement is some numbers are given and you have to write the hash table using open addressing hash table using the linear probing. Okay. So the first technique we are going to use is linear probing. Please ignore someone's mic is on. Okay. I need to take the next slide because so linear probing means what? Just find out the index. Now this is the index, suppose from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now your first number is 4371. Now for 4371, your value, table size is given, yes, 10. Hash function is given itself. So h of x is equal to x mod 10. So 4371 mod 10, what is the value? It's 1?
1.
Yes. So you need to place 4371 at index 1. Now after that, second number is 1323 mod 10. Mod value is 3. So I am going to place it at index 3. Now your next number is 6173 mod 10 is equal to 3 again. Now here collision occurs because at index 3 we have already placed 1323. So to place 6173, as we are applying the linear probing technique, you just have to find out the next empty position. So next empty index is 4. So I am going to place this 6173 at index 4. Okay, it's a simple thing. Now next is 4199. Now 4199 mod 10 is equal to 9. So I am going to place it at index 9. 4344 mod 10 is equal to 4. Okay, but 4 is not empty. 4 is already occupied by 6173. Okay, so again for placing 4344, we need to find out the next empty position. So next empty position is 5, 4. So I am going to place this 4344 at index 5. Got this? We are using linear probing technique. We are not using replacement technique with replacement, without replacement, and nothing. We are just checking the next empty position and we are placing the element, your key at that index. It is a simple thing. Okay. Now after 4344, your next number is, I will write here, your next number is 9679. Now for 9679 mod 10, again it is 9, but 9 is not empty. So next position after 9, which is empty, is what? Yes?
0.
0. Correct. So I am going to place 9679 at index 0. Now after this, next is 1989. So 1989 mod 10 is equal to again 9. So where should I place this? Tell me the index.
Second.
Second. Correct. So 1989. So this is the first bit of your problem. That is open addressing hash table using linear probing. Got this? Yes? Is this clear?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Now the next technique is, or next second point is open addressing hash table using quadratic probing. Okay? Open addressing hash table using quadratic probing. Now in quadratic probing, the hash function we are going to use is h key is equal to key plus I square mod m, where m is the size of table. You can consider the size of table or the primary number. Okay, so as we are assuming m as 10, so let's calculate again. So my table is 0, 1, 2. Now 4371 mod 10. 1 is empty. So I'm going to replace, I'm going to place 4371 and index 1. So 1323 mod 10 is equal to 3. So 1323 at index 3. Now after that, next number is 6173, which also demands for the same index, that is 3. Okay. So as collision occurs, we can apply the quadratic probing technique, that is the quadratic key function. Okay. So for that, we have to consider the values of I as 0, 1. You need to check this. 0, 1, 2, 3, like this. Okay. So let's take 0. So 6173 plus, oh sorry, h of 6173, h of 6173, that is the index for 6173 is just wait a minute. Hello. Yes. Now here, your actual key is 3. That is the value of index is 3. So 3 plus I square, take the value of I as 0 first, I square mod 10. So 3 plus I square mod mod 10 is 3 plus 0 square, that is 3. 3 plus 3 mod 10 is 3. So 3 is already occupied by 1323. So you cannot take the value of I as 0. So next value take as 1. So 3 plus 1 square mod 10. 3 plus 1 square is 3 plus 4, that is 4. 4 mod 10 is 4. So 4 index is empty. That's why you can place 6173 at index 4. Got this? Yes. Got it?
Yes,
Yes,
ma'am.
ma'am.
Okay. So I'm going to place this number, that is 6173 at index. Okay. Now after this, next number is 4199. 4199, index 9 is already empty. So you can place 9 directly at 4199 at index 9. So after 4199, next number is 4344. But 4344 number is already index. For 4344, you will get the index as 4. But we have already placed 6173 there. So check the quadratic probing. So apply the hash function for the quadratic probing. for number 4344. So now the previous key is 4. 4 plus 0 square mod 10. What is the value? It is 4. So we have it is already a collision here. So again 4 plus 1 square mod 10. 4 plus 1 square mod 10 is 5. Okay. So at location at index 5 I am going to place 4344. Okay. So after this next number is, yes, what is the next number? What is the next number? 9679. 9679. 9679 mod 10 is 9. 9 is already occupied. So again use the function. So 9 plus 0 square mod 10 is, yes, what is the value?
9.
9. 9 is already occupied. So 9 plus 1 square mod 10 is equal to, yes, what is the value?
0.
0, correct. So we can replace this, we can place 9679 at index 0, 9679. Got this? Now what is the next number?
1989.
1989. I am just explaining the things, so I need to erase something, I need to use that place, but while solving the problem in your notebook, please write down very systematically. What is the number? Can anyone please tell me? Next number? 1989. So again collision occurs here because ninth index is not empty. Okay. So let's find out the next index by using the quadratic probing again. So take the value of I as 0. Now if you take the value of I as 0, I think you will get 9 again. Okay. So let's try for the value 1. I is equal to 1. So 9 plus 1 square mod 10. What is the value?
0.
Can you please check? Yes?
0. Already occupied.
0. Okay. So it is also occupied. So you need to consider the second next I value, that is 9 plus 2 square mod 10. Yes, what is the value?
3.
I think it's 3.
Already occupied.
Yes, 3 is already occupied. So 9 plus 3 square mod 10. What is the value?
8.
8. So 8 is empty.
Yes, ma'am.
So you can place here 1989. Got this? It's a simple.
Yes.
Is it simple?
Yes.
Okay. So let's go ahead now. Now the next third bit in the same problem statement is, okay, I need to change the slide now. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. Now the third is open addressing hash table with second hash function. Okay. So let's solve this problem by using the second hash function. Again, first number, that is 4371. Okay, now is it okay if I just find out the index and I will, if I not write the table, because it takes too much space in the screen, no? So I'm not going to write the table. I will just find out the index. Okay, you please draw the table, that is index and key, and whatever the key we are going to find out, just note down the that key in front of that index. So 4371, you will get index as 1. So note down the number at index 1. I will give you two more minutes to draw the table. Draw the table quickly. Index from 0 to 9 and key. And in front of index 1, write down the key as 4371. Finished? Let me know when you finish. Yes, finished or not?
Yes, ma'am, completed.
Completed? Okay. Everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Now the next number is 1323. What is the index? 1323. What is the index?
3.
3.
3.
Ma'am, 3.
So note down 1323 at index 3. लेक्चर चालू
मला जरा काम आहे लेक्चर काम करता
हो
आपल्या मॅथ्स रिलेटेड आहे
चालेल okay now next number is 6173 6173 mod 10 is equal to 3 here collision occurs hence we need to apply the second hash function now okay now how to apply the second hash function now after the 10 next primary number is 7 okay so your function is 7 minus 6173 mod 7 is this correct yes is this correct
Yes, ma'am.
yes so 7 minus 6173 mod 7 is 6 please check the value is it 6
Yes. Yes, ma'am.
yes yes okay so 7 minus 6 is 1 that means you need to jump one position after 3 you need to take one jump okay so place 6173 at index 4 okay got this
Yes, ma'am.
okay now the next number is 4199 index 9 is empty so place 4199 at index 9 now after that 4344 index you need to place that at index 4 but index 4 is not empty so again apply the second hash function so 7 minus 4344 mod 7 yes 7 minus 4344 mod 7 what is the value please check yes it's 3 or 4
4, ma'am.
4 so 7 minus 4 is 3 now actual index is what actual index is 4 so after 4 you need to take 3 jumps so 5 6 7 so at index 7 you can place number 4344 got this बरोबर आहे का चला लवकर रिप्लाय करा is it correct 4344 If it's correct, then take the next number. Your next number is 9679. Now 9679, index 9, that is not empty. So again, for 9679, 7 minus 9679 mod 7. Yes, what is the value? Yes,
5.
5.
मैम 9 empty है ना?
9679 mod 7.
Yes, ma'am. 5.
Yes, ma'am.
It
5.
is 5. So 7 minus 5.
2, ma'am.
Yes, it's 2, but what is the actual position? It is 9. So after 9, you need to take the 2 germs. Something is wrong.
मैम 9th position already empty आहे.
No, we have placed 4199 at 9th position. No?
Yes, ma'am.
Your 9th position is not empty. We have placed 4199. No? What is the number? 9679. No?
Yes.
What happened here? We have placed 6173 at position 4. Okay. Because by using second hash function, you get 1. So 3 plus 1, that is, we can jump one position, you can take the one jump from 3. Okay. After that, number is 4199. We have placed that number at index 9. Okay. So after that, your number is 4344. So 4344 index 4, which is already occupied. So we have calculated the index as 4344, 3 jumps. Okay, from index 7. Sorry, 3 jumps from index 4, that is place 7. So at index 7, we have placed 4344. Okay, after that, your number is 9679. 9679 mod 10 is 9. Okay, take the another number. Suppose your number is 1989. 1989 mod 7. Okay, calculate this value 7 minus 1989 mod 7. Tell me the answer. 7 minus 1989 mod 7.
Ma'am, 1.
1. 1989 mod 7 is 1. So 7 minus 1 is 6. Isn't it?
Yes, ma'am.
So after 7,
Nine.
after 9, you need to take the jump
6 jumps.
at 6th
Index
position.
5.
At index 5, but at index 5 is also not empty. That means you can say, and even if you calculate for 9679, it is also 1, isn't it? Your answer is 2, na? So after 9, in 2 positions, 0 and 1. So after applying the second hash function for 9679, you will get the index as 1, and that is also not empty. That means by using this second hash function also, you cannot, there is no place in your table for 1989 and 9679. Okay. So now I think the idea of rehashing is clear. Why we are going to double the size of table. Got this?
Yes, ma'am.
Got it? Everyone? So you can make a note below this table as there is no place for 1989 as well as 9679. Okay. So I will give you the next problem statement. Please solve that statement as a homework. You can send me the answer on my WhatsApp. I will check it. Okay, I will take a screenshot here itself. Is there any problem in the first example? Yes, is there any problem in the first example?
No, ma'am.
No, ma'am.
Is this visible?
Yes, ma'am.
No. I will not click on the OK button. Please note down the example. Explain linear probing with and without replacement using the following data. 12, 1, 4, 3, 7, 8, 10, 2, 5, 14, 6, 28. And you need to assume the bucket size from 0 to 9. Each bucket has one slot. So calculate average cost per number of comparisons for both. Okay. So just try to solve the first part, that is try to just put this data by using the linear probing with and without replacement. Okay. So shall we stop today? Can I stop my presentation? Just wait a minute. I will give the link for today's practical attendance, link of attendance.
Can you please choose the question?
Link is there in the chat box. Code is given. Enter that code while filling the attendance form.